Alright, again, I'm going to show you here how I wired up this Big Bang type relay temperature controller. It's got a heat and a cool setting, but I'm just using it for my incubator, so I don't really care about the cool setting. And you can see on the back of it, it gives the little pin numbers and what they're for. That's, open relay, the power input, and then here's where your controller, your temperature sensor connects, which is a thermistor type control, or sensor, I mean. And what I've done here is I did the same thing I did with my humidity controller. I kind of try to keep my power lines all separate, my power feeds, so that way, if there's a problem somewhere, I can figure it out pretty easy. So on the back here, running the power, I have this power cord that comes in. Right there. Both sides of it, one on one pin, one on the other pin. And then going out of it, okay, I have another power cord that comes in. This power cord is going to an electrical outlet, which is where I'll plug in my heater. Okay, so the wire in here comes in and goes to this side. Alright, now, the other side of that electrical wire goes to one side of the relay. Then the other side of the relay, I have a wire that comes out and goes over to the other side of the electrical outlet. So what that means is when this kicks on, it activates that relay and says, hey, I need to heat up. It's going to engage that power line supplying power to the heater. So then the heater will start heating up, goes to whatever temperature, and then it turns off. Now, I got a visual aid here I got to grab. Since this is a Big Bang type relay, what happens is when you turn it on, it starts heating up and the temperature will start to go up and up. And it gets right here's your set point. Okay? So depending on your heat controller, it'll either turn off here or it may have a little bit of a fuzziness to it where it may go a little bit above it before that relay actually turns off. Now most of the controllers like this, they have settings in them where you can change it. You change your slew rating or whatever it may be called for your controller, because they are different depending on what the manufacturer makes it and whatnot. But what happens is your heater, because it's hot, even though it kicks off, it'll still release that heat into the environment, so your temperature will actually go above what you want it to be. And then eventually it'll start to fall back down. And when you're using a little styrofoam incubator like I do, the temperature falls pretty quick. So all you got to do is look at the maximum point where it starts to fall, and then when it comes back down here, the heater kicks on. It takes a little while to heat up, so then the temperature will fall even further before the heater starts putting out heat. And then you repeat the same process. The heater will turn off, but the residual heat will push the temperature up. And so when you're setting whatever your set point is, you want to set it so the average in here is whatever your whatever you want your eggs to be at, basically. So with mine, it's pretty easy to do because I don't really have to take into account time, because the temperature rises and falls pretty quick. If you got an incubator that's really well insulated, you don't want it to push all the way up here and then sit there for a long time before it falls, because then your average temperature of your eggs will be too hot. So you kind of have to figure that out where you need it to be so that your eggs come out the right temperature. Now what I've done with the incubator was I ran, let's get it up here, I ran a power cord. One side of the power cord goes to one side of the heater and the other side goes to the other side of the heater. And then you just plug it in to the electrical outlet. Now you can wire that straight into your controller if you want, whatever. What happens with a lot of these controllers though is this one's rated for 110 volts through this relay. Now you may have a relay that's only 32 volts DC or 12 volts DC. What happens then is you have to have another relay sitting here in the middle where these two wires will connect to the output side of that relay, which is powerful enough or strong enough to take whatever current you're pushing. And then your two leads from here will come out to this side of your relay to actually control a relay that's going to power on and off. And when I mentioned slew rating, you'll have your set point, say it'd be like 37.5 degrees Celsius. Your slew you'll want to set like 0.1 or 0.2 degrees so that it actually won't kick back on until it hits like 37.3. Because if your set point's 37.5, when it hits 37.5, it's looking and it's like, hey, I need to turn on and I need to turn off. So your relay will bounce, and with these mechanical type relays that's in this specific controller, it'll end up burning out the relay pretty quick. It'll fail on you. And then it'll either fail open, which means you get no heat, or it'll fail closed, in which point your heater never shuts off. So that's something to keep in mind. But yeah, I think that's about it. I'm actually about to remove this controller and put a new PID controller I got on to experiment with it. Good luck, everybody.